Hi, welcome to Physics Teacher. In this video, I'm going to go over how to balance nuclear equations. It's a tutorial for my grade 11 physics class, so stay tuned. Alright, so I have four equations here. Here we have alpha and beta decay, and then we have an example of a fission and fusion reaction. In each case, we have numbers here that are written above. These are called our atomic mass, which show our total number of nucleons, so sometimes called the nucleon number. Nucleons is just particles in the nucleus, so those are our familiar protons and neutrons. And then the number down here is our atomic number, which we know is the number of protons, but for a nucleus, it also shows us our charge. Now these two numbers, the ones on the top and the ones on the bottom, are two separate conservation laws. So we have our conservation of nucleons, which is saying the total number of nucleons must remain constant, and we have a conservation of charge, saying the charge must be constant. So in this example, we have radium undergoing an alpha decay. Now an alpha decay is just a helium nuclei, and so sometimes we can write, instead of this alpha, we write the symbols He. And now what we need to do is determine what this unknown element X is. So if we start off with conservation of nucleons, we can write down an equation, just 226 equals Z plus 4. Right, and then you can solve for Z. So Z is going to equal 226 minus 4, or 222. And we can do the same thing with the bottom numbers, showing conservation of charge. So 88 must equal A plus 2. So rearranging, we get A is 88 minus 2, or 86. So our unknown element X must have an atomic mass of 222 and an atomic number of 86. We'll look at your periodic table and see which element has an atomic number of 86. And we get radon. Now in our next case, we have a beta decay. So in a beta decay, we have an electron shot out from the nucleus. And that happens when a neutron will turn into a proton and eject an electron. And this is what a beta negative decay would be. You can have a beta plus decays when you eject a positron, because a proton turned into a neutron. And then this is an anti-neutrino. So whenever we get a beta minus decay, we get an anti-neutrino. If we have a beta plus decay, we get a regular neutrino. But let's focus on what this element here is. So let's do our conservation of nucleons. So we have 234 equals Z, and then plus 0. Now the neutrino we don't really consider. It would technically be 0 and 0 because it's not a proton or a neutron. It's its own very, very tiny particle, and it has no charge. So we don't need to worry about it in our conservation. But it just tells us that Z is 234, so that actually hasn't changed. What has changed is that a neutron turned into a proton. So if we look at our conservation of charge, we have 90 equals A plus a negative 1 charge. So if I rearrange that, we have 1 extra proton. Of course, well, a neutron turned into a proton. So that means this unknown element is 234 and 91. So check your periodic table, which element has an atomic number of 91. And we get palladium. Now this is a fission reaction, so we're shooting a neutron into a uranium atom, and it's splitting into 2 lighter atoms and emitting 3 other neutrons. Now what is this element right here? So let's start with conservation of nucleons. So we have 235 plus 1, so 235 plus 1 is going to equal 146 plus Z plus, and we have 3 neutrons, so plus 3 times 1. Okay, so a little bit more complicated. Let's rearrange this. We have 236, and then let's subtract 146, and we'll subtract this 3 as well. So we're bringing the 146 and 3 to the other side of the equation so we can calculate Z. And we get Z equal to 87. Now we need to do the same thing for conservation of charge. So we have 92 plus, well, this is a 0, so neutrons don't have a charge. It's going to equal 57 plus A, and again plus 0 because neutrons don't have a charge. So we're left with solving for A, which is 92 minus 57, which is 35. So our unknown element has an atomic mass of 87 and an atomic number of 35. And if you look up 35 on the periodic table, we get bromine. Lastly, here we have a fusion reaction. So we have two isotopes of hydrogen. This one would be deuterium, and this one's tritium. And they are going to form something, plus another neutron. So let's figure out what this is. We'll start with conservation of nucleons. So 2 plus 3 is going to equal Z plus 1. So rearranging, we get Z is equal to 4. And conservation of charge, here we have 1 and 1. 1 and 1 plus 1 must equal A. So A is equal to 2. So our unknown element is 4 and 2. We know that as helium. Well, I hope this tutorial helped, and if you have any further questions, let me know in the comment, and don't forget to subscribe so you don't miss the next tutorial.